Hello everyone, I am Praveen Kalugovila. This research is about effectiveness of proposed external water supply for whitewater rafting from Broadland Hydropower Project. This is the layout of Broadland Hydropower Project. Here you can see the main dam, and this is the confluence of Kithulgala and Muskeli River. This weir is situated in Kithulgala River, and water from this weir conveys to main dam through this diversion tunnel. Whitewater rafting is starting from this point, and it continues to downstream of the river. This study is conducted for this area of the river. Here you can see all the rapids that are used to conduct whitewater rafting in the Kithulgala River. These two purple circles show the third degree major rapids. What is rapid? Rapid is a portion of the river where river bed has steep gradient. This causes the increase of water velocity and the turbulence. Here you can see conducting whitewater rafting in rapids. Whitewater rafting in Kithulgala River is listed under 10 best locations for whitewater rafting by International Rafting Federation. Problem statement of this study is 13 of the 18 rapids will be diminishing because of the Broadland Hydropower Project. I will explain the methodology used in this study here. First, I used a graph for this flat modeling. The terrain of the selected portion of the river were delineated in this digital elevation model. Then upstream boundary conditions were calculated using area ratio method. This was given as a flow hydrograph. Then the boundary conditions were given as the normal depth of the river. That was calculated using the digital elevation model. Then the flood model were generated, and then flood model calibration were done manually by calculating Nash Cliff coefficient, RSR value, and P-bias values for observed and simulated flow hydrographs at downstream gauging point by changing the Manning's N value for the model. After the calibration and validation was done, upstream boundary condition of the model was changed to the flow hydrograph of the proposed external water supply. When it comes to the result of killer fall rapid, you can see in dark blue line the water level before the dam is commissioned, and the light blue line is the water level after the dam is commissioned. According to the literature, water level should be 0.5 to 1 meter to have a good rafting experience. But in this rapid, we can say after the dam is commissioned, this portion only satisfy the requirements, so that whitewater rafting can be conducted only this portion of the river. For the whitewater major rapid, results are pretty much same as the killer fall. This graph shows the result for head chopper. It is a second grade rapid. You can see there is a huge reduction of the flow velocity of the flow, but there is a less reduction of the flow depth, so that we can say comparatively to the other third grade rapids, second grade rapids get lesser impact due to this Broadland Hydropower project. As for calculation, we clearly can say that only the portion from the cross section of river can use for whitewater rafting. Although the water depth requirement were achieved, velocity requirement should be measured by carrying out a study. According to results, we can say whitewater rafting can be still conducted after commissioning Broadland Hydropower project, but there is a risk of rafters getting injured and boats and equipment getting damaged. We can recommend that increasing the external water supply on January-March dry season, and it can be reduced in wet season. For the future directions, it is recommended to carry out a study to check the velocity requirement. and the other future directions are listed down in this slide. This is the end of my presentation, and thank you.